Hi, Math 6 again. All right, so this video is the most updated video, right? It's a video on the most recent lesson, which is the surface area of 3D solids. Now, up until this topic, we were talking about how to find the perimeter and area of 3D figures, and then we enter the 3D world. Sorry, we were talking about how to find the area and I am mumbling. Area and perimeter and circumference of 2D figures, and then finally fancy Nancy 3D solids. Ta-da! All right, so that's that. Here we go. You guys want to classify some? So the 3D solids that you guys know. All right, the most common one, the easiest one. What is this? Oh, come on, Mrs. Moon. So this is right here. What does that look like? To me, or at least I try to draw a cube. Cube has side, side, side. You see how the length, I try to label it length, and then width, and then height. They're all congruent side, right? All equal side lengths. And that is a cube. Okay? And then a cube would have a net 2D figure, 2D drawing of a 3D solid. It's like a flattened drawing of a 3D solid, right? So we talked about how to count the vertices and the edges and the faces, number of faces of 3D figure. So should we count it for fun? It's been a while, you guys. Vertex. Vertex is a point where two edges meet. So, and plural form of vertex is vertices. 1, 2, 3, 4. Yeah, I will use green in 1 second, honey. 4, 5. Let's cut. Summer. 1, 2, 3, 4, 5, 6, 7, and then 8. 8 vertices. Okay, and then edges. 1, 2, 3, 4. Bottom there. In the same sense, 1, 2, 3, 4. 4 more, right? And then the side ones, 1, 2, 3, 4. There are 4 in total. It is 12 edges. So let me write down what we just talked about. So what we know is that there are 8 vertices and 12 edges. And then surfaces. Should we look at surfaces? It's the side 1, 1, 2. They're facing each other, they're congruent, they're parallel, okay? That's 2 faces. Ready? And then there's top 1, 1, 2, top and the bottom ones, right? That's 1, 2, 3, 4 so far. And then what have we not counted? We have not counted, guys, it's really confusing because the colors are overlapping, but do your best. There is this one, front and the back. You see what I'm saying? So there are like 3 pairs of opposite faces, opposite regions that are like facing each other. They're parallel and congruent. So what did that say? It means there are 6 faces. Okay? 6 faces. And then let's confirm our understanding by drawing our net. When you've learned to find the surface area of a 3D solid, you can't do that without drawing a net. So here is the base. I always want to shade the bases. I always want to shade the bases. That's my base right there, okay? And then there's another base like that. There's another base like that. And then, obviously, we said there's 6 faces in total. This is base. That's base. There better be 4 more faces. They're called the lateral faces. So 1, 2, 3, and then 4. It doesn't matter where you put it, guys. It doesn't matter where you put it. So these are called the lateral faces. Therefore, what's the magic word? Surface area. Surface area is found by finding base area and, meaning addition in mathematics, and lateral area. Surface area is a combination of base area and the lateral area. Okay? And what we call sabala. Sa ba la. We're good? Now, let me give you some dimensions. Okay? So it is, here we go. Let's say this is 5 inches, which means this one 5 inches, right? That means, and then height is 5 inches because it's a cube. So this is 5 by 5. And you know what else is 5? It's this one, height. Matching game, 5. Matching game, 5 and 5, right? And because this is 5, that better be 5. Everything is 5 pretty much. When you draw a net, in surface area, in finding surface area, nets are absolutely necessary. That's the best way to visualize the surface area of the figure. Okay, so don't tell me, oh, I try to follow the book, the way introduced in the book. I don't know. I mean, I know what the book shows, but the best is that you visualize the solid by yourself, and then area, and then count the areas. Okay, so here we go. You know this one right there, that is 5 by 5, right? So the area is 25. How many squares, you know this is square because it's 5 by 5. How many squares like that do you have in a cube? I mean, how many square faces do you have? There's 1, 2, 3, 4, 5, 6 of them. Therefore, you will multiply 20 by 5, which is 150. What was it? Inch square, because we're talking about area. Okay, so that's how you find the area of a cube. Next, hey, what do you think it should come after how to find the area of a cube? Which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Mr. Moon is sneezing. All right, here we go. Do you remember what this is called? This is a rectangular prism. Okay, this is a rectangular prism, which is, this is rather more, obvious. Do you guys see that? This right here, base, top, bottom. Sure, those are my bases, right? So here we go. The number of vertices and edges and faces, they're the same. Surface area, magic word. Ready? Sabala. Finding surface area of a rectangular prism means, I'll explain it in terms of its net. It means you have your base here, right? And then you have its matching base up there. Let me throw in some dimensions. Let this be 10 inches, okay? And this be 8 inches. And let this be 4 inches. Ready? If that is the case, then I will label my base 10, 8. Isn't that right? Ooh, that doesn't look realistic because height of the prism is half of the width of the base. So that matching game, because this is 10, that must be 10, that must be 10, that also must be 10. This is how you label your net. The more you label, the easier it becomes for you. Because opposite side is 8, you see what I'm saying? And you know from our 3D drawing, the height of the prism is 4. Matching game again, that better be 4, right? And you know from what you've been doing with me in class, you know right here, right there, because this is 8, that better be 8. We've been talking about this for a long time by now, right? So that's 8 and this is 8. Matching game, this is 8. Matching game, therefore this is 8. This is 4, matching game, that better be 4. Oh, wow, why did I draw this part? Sorry, guys, I wasn't thinking. Anyways, how many faces how many more faces should I draw? You guys think about it. think about how many lateral faces you have all around the prism. It is 4. Why? There is a face under each side of the base. There's 1 and there's 2 and then there's 3. You know what I mean? And then there's 4th one. So I'm going to draw 4 faces, lateral faces. Okay? So let me continue. All right, ready? Matching game. Because this is 8, that better be 8. And hey guys, only do the matching. Don't guess the dimension lengths, okay? Because this is 8, that better be 8. You know? And right there, matching game 8. What did you say? You see 4 different colors and you're drawing one more lateral face, right? Where should we put it? It doesn't matter. It really doesn't matter. So I'll just put it right here. I'm going to draw a little longer like that. Why? Think about it. The reds will come together like that, right? 8 and 8. That means this side right here will fold onto, not onto it, but it's going to come together with that 10-inch length, which makes this one 10 as well. Matching game, 10. Hey, matching game, 4. I love matching games. All right. That's my net. That's my net. Guys, please do not try to find the surface area of any 3D solid without drawing its net. It becomes a lot easier when you actually visualize, oh, what area, region, what face am I finding the area of? It's really confusing, especially when all the faces are all rectangles. It's confusing, you guys. So, check this out. How to find the surface area of a rectangular prism. You pretty much have to find the area of all the rectangles. How many? 1, 2, 3, 4, 5, 6. 6 of them. You guys ready? Let's do it. Hey, what was the magic word? Sabala. Base area. Okay, so base area right here and then down here. And the area is 10 by 8, right? So which is 80, but then there are 1, 2 of them. So you have to double it, times it by 2, okay? So we got the base area plus, what about lateral area? Do you know what I noticed? I know you guys noticed this too, but this right here is congruent to that, okay? That's by dimensions. So 8 by 4, which is 32, which is 32 here as well. So we're adding that 32 times another 2. Last one. This rectangle is congruent to that line because it's opposite. It's like facing it. You know what I mean? Like that. Okay? That could be a random pair, but you know, you get my point. So let's set that up. Include that in our calculation. Plus, what was the area? It is 4 by 10. It's 40 here. So is this. Right here, 40 times 2. You get it? All right, so this gives you 160 plus this gives you 64 plus this gives you 80. Can we do the math? 160 plus 64 plus 80. Oh gosh, it's difficult. 4. This all together, I believe, is 20. Carry, and that's 304. Hey, what's the unit? After all, you're talking about area, right? So something must be squared. It is inch squared. La, 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 la. Okay, beautiful. So that was a cube, and here was a rectangular prism. You guys want to do one triangular prism with me? Okay, so triangular prism. Let me do my best. Drawing my well, you know what? Let me make it easy for myself. How about this? Okay. Visualizing my solid. All right, triangular prism. Why is it called a triangular prism? Because if you look at the base of the prism, the base shape is triangle, right? So if you were to draw the net, it's surface area is all about visualizing the net of the solid. Here's my the orange triangle. This is upside down form of it, right? I better give you some dimensions. So let's say if I ask you to find the surface area of the entire thing, I better give you proper dimensions of the triangles so you can use them towards finding the area. I must give you the height, right? And that is 2 inches. And make this base, let me see, 3 inches. How about that? Okay. And make this 4 inches. I like to give you different numbers. All right. So base of the prism is 2 by 3, not 2 by 3. Height 2, base 3, and height of the prism is 4 inches. Ready? Action. You're just gonna copy it. Copy. Okay, 2 by 3. Matching game. 3. Let's go. And what else is matching? Height of the base. Other base. All right, other base. You get it? All right, now, whoa, what just happened? Yeah, okay. Now, you guys think about it. How many lateral faces does this prism have? Obviously, there is this one right in between, right? And there is, I mean, you think about it. Base is 3-sided. Base has 3 sides, right? 1, 2, 3. So each face under each side, it better be one, the green one right here. And then the second one, I'm gonna shade the one in the back, right? The one in the back, and let me add it to the net. Yeah, the purple, like that. And then there is this side one right there. The side one right there. Like that. Okay? So, what are we going to do? Do we label everything? No. We forgot to label the height of the prism, which is 4, 4, 4, 4. It's got 3 lateral faces and 2 bases. We are done. Get it? All right, so that's in terms of the drawing the net, right? Let us find the surface area. Sabala. Sabala. Base. Bases are 2 triangles, isn't that right? And then lateral areas are 3 rectangles. Okay? 2 triangles. Let's find the area of 2 triangles. Each one, 2 times. What times what times? Isn't it base times height? So base times height divided by, no, not 3, sorry. Base times, base is 3. So 3 timing by that by height, which is 2, divide that by 2, right? And there are 2 of them, so you double it. Now, does something catch your eye? So 2 divided by 2, you can reduce that. So you eventually have to just multiply 2 and 3, which is 6, plus 3 rectangles. Now, I only know, if you pay attention, this side of each rectangle, right? So I should have given you guys here, right there, 4 inches, okay? So that means this would have been 4. Matching game, that would have been 4 as well. Get it? And let me make this one 5 inches. That will be 5 here. Matching game, 5 there. That will make this one 5 as well, isn't it? And because this is 4, this side right there is 4. That's my complete net. Sorry. So what's going on? How to find the area of each rectangle? There are 3 of them, right? 4 by 4 gives you 16. Okay, we're not timing one rectangle area by 3. That is not what I meant. This is area of 3 different triangles, unless the base is an equilateral triangle. But anyways, 16 plus 3 by 4 is 12. And last but not least, 5 by 4 is 20. Yeah, so those are areas of the 3 different triangles. All right, so let's do some math. That is 16 plus 12 gives you 28, and then that's 48. Haha, found it. 54. After all, it's area, right? And what's the unit? Inch. So area, inch square. Ta-da. That's it. Very good. Now, should we do cylinder? Okay, so cylinders. Cylinder is like a prism. It has a pair of parallel and congruent bases. So cylinder has 2 bases that are congruent and parallel. And let me shade them. I like to shade bases. They are my bases. What shapes are they? Guess what? They're circles. I better give you radius. I better give you height, okay? So radius, make it 3 inches. I want to make height. I like to make height 10 inches because eventually we'll multiply, the product of many numbers by 3.14. I like to get rid of the decimal. Anyways, so you know what? No net, no surface area. So here's my net. My 2 bases. So that's my net. Now my radius is 3 inches. My height is 10. That's all I have, right? Now, sabala. Surface area is a combination, sum of two base area, meaning circles, and area of this rectangle, isn't it? So let's set it up. So that is 2 circles plus area of a rectangle. Okay, 2 circles. Area of a circle, isn't it? Pi r squared, right? Plus area of a rectangle. I already created a video on that. Length and width, length by width. Width is 10. Length is, this is the most important of the lesson. Length of a lateral face, that rectangle is same as circumference of the circle. I can't emphasize enough the importance of you understanding it. Okay, so circumference of the circle is the length of the rectangle. Circumference formula is pi. See, even I get confused. 2 pi r. That's not a z. That's a 2 official. 2 pi r, which is 2 times 3.14 times what's the r? 3. That is same as multiplying 2 and 3 together. First, totally allowed, 6 times 3.14, which is, oh gosh, gotta do some math. 314 multiplied by 6, 4, carry over 2, 8, and then 18. And then 2 decimal places, therefore 18.84. That is the length of the rectangle. So therefore, it is L times W. So it is 18.84 by, what's the W? 10. Oh, I should have given you 100. Okay, so that is 2 times, pi is 3.14 times, what's R again? R is 3 inches. So 3 inches squared, that's the area formula, plus 18.84 times 10. You're just moving the decimal to the right ones. So 188.4. Hey guys, guess what? Let's do some calculation. Gem that tells you to not multiply first, but exponent first. Do exponent first, which is 9, not 6. Please, let's learn this, okay? So it is same as 2 times 9, which is 18, multiplied by, or it really depends. I mean, I don't mind doubling this first. Okay, so 6.28 times 9 plus 188.4. Oh gosh, this is a lot of calculation. You guys saved me. 8 times 9, 72, 7. 2 times 9 is 18, 25, carry over 2. 6 times 9, 54, 56. And what was it? 2 decimal places, so 56.52 plus 188.4. Oh, we're almost there. Oh my gosh. So when you add decimals, you do line up the decimal place points. You do. When you subtract decimals, you have to line up the decimal points. When you multiply and divide, you don't line up the decimal points. Please, you gotta learn this. Calculate from right to left. 2, 9 point, and then 4 carry, 4, 2. Guess what? We're almost done. Okay, so what's the unit? Inches, but we're looking for area. Inches square. I did it. We did it. Oh my gosh. I am proud of myself. I did all the calculations and I got it all right. Okay, so surface area. All these areas together, okay, which make up a cylinder. Okay, that's a beautiful looking cylinder, is 244.92 inch square of an area. We did it. Oh my gosh, you're gonna ace the quiz tomorrow. I'm so ready for it. Good job, guys. Better listen carefully and actively. You math geniuses. See you tomorrow. Love you all. Bye. What is this? How do you turn this off? Oh, no.